I hear my voice.
Actually, I'm not that happy with the sound, but luckily I took this with me, so I'll try to connect it.
You can pass
Maybe hopefully
yeah.
then it will sound like you're, here
Good,
doing the
good.
presentation next to the laptop and the screen. Jah, oota, siin alles sätime ju.
And actually, Pete, if you like, you can just press where's the button, my view, there's option full screen mode. So yeah, maybe.
Wait, no, wait, I'm handling the audio stuff. I'll deal with
then yes, cool.
Okay. Guys, can someone speak something?
1, 2, 3. 1, 2, 3. Hello.
Okay.
Good.
I guess this one is better. A little bit more bass and stuff, and I'll just handle the volume live.
Okay.
Okay. 10 more minutes. I'll rotate the screen or the laptop.
Saatsin tudengid varem ära, panin kohe tulema. Tegin konfliktitööd mul ära. Näed, sul on veel 10 minutit aega. Tutikas saad sirvida. No, jäta meelde. Ma vaatasin. Ei ole. Okei, no SV kodulehel on kirjas ka. Okei.
Siis ta oli seepärast.
Mis ma ise hakkan? Ma naeratasin, et andis 10 tükki.
Ja. Mul on ka neid mingi... et neid asuta kõik.
Naeratasin tõrkule 109 tükki.
See on mingi reklaam. See on platvormil.
Ei, kurat, neil ei ole. Minu arust neil on need talaripud välise kõrvaga sisemise kõrvaga. Ma ise konsulteerin seda arrast tahab ka endale mingit kandeline tabelist saada. Ma olen 400 toodet läbi näinud oksendamiseni. naine läks ära ja mis on teinud. Miks on sul sõna Instagram pooleli süüd? Instagramis toimub naiste omavahel kõik harjumise suhet. On. sa ütlesid spektrum, kuidas see oli? Yes.
Pigem
see. Ja see oli nüüd SV, esmaspäeval saame kokku seal harrastustehases Kokenini euroga ka. Ja siis ongi see, ja no ma lasin ilmselt tüdruk majandada tegemist, lepime kokku ja näed, alles on kõik mõtlesid. Aga peaks nagu vaatama. Oli seal, ei ma ei tea, sa ei pannud teada. Noh, kõik tudengid teavad ilmiga. Ja ei no lihtsalt ära tulnud, lihtsalt kui enam. Väga kusjuures ma käin seal hästi tihti, seal ütleme perioodversioon, iga ma käin seal meil on maad, siis ma käin seal sauna tegemas ja mõtsa tegemas. Seda kogu aeg, mis on see Põlvase ümber, vaata, kus sinna peetakse siis käinud 1,8. Sa tunned, no ma tulen Moosti poolt sisse, 2 ringristmikku ja põhimõtteliselt sõidad läbi mäest üles, nagu sul mäest üles tuleb, siis vaadanud, kui on rohus. Minu arusaama järgi on seal sees. Kokkuvõttes kõik on tipp Eestil. Minu jaoks ta ongi põlv, ma ei tee nagu vahet, see just neid põlve rõivist. Kokkuvõttes on nii vast. See õnnestus üks suur asi ja kirjutasin tudengile soovituskirja CERN-i suvepraktikale. Usun või mitte. Mõtlesin, et vaid fakt lasta. Hiinlased indid väga kaotavad. kas keegi võiks bussist mõne selle haamrivarastuse klaasipuruks leia?
ma juba panin tempi madalamaks ja venti lükatakse ka juurde, loodetavasti. Suht umble on jah, olen nõus. Okay, so we are quite close to the start.
Okay.
Valters, can you say something just in case you'd like to hear how the sound quality is?
Yes, hello. Can you hear me?
Okay.
Yes.
Looks like hear you well, loud and clear. Okay. Okay, I guess I'll just start with the intro and then I will give you the floor. Okay, few minutes, please. Sorry, there was no sound. You didn't hear me, but basically, I did a little intro for you.
Great.
But the idea is that
I know everything about myself already, so
yeah, the floor is yours. I will mute the microphone and go ahead.
Yes. So hopefully you can see my screen. Oh well.
Wait 1 second. Kus see full screen on? Panen lihtsalt 2 klikki ja okay, so we got the full screen mode enabled.
All good?
Yeah, it was tricky, but okay.
But you did it.
Yeah, I did it. Proceed. Thank you.
Great. So thank you for the introduction. I hope it was good. Yes. So I will introduce myself a little bit as well, and my company. I'm very happy to be here to see that it's good weather in Estonia as well, and Friday has come for engineers, and the weekend is up. But to finish the week off, yes, then my name is Valters Sejans. I represent company Primex. Primex is a company known for steel fiber reinforcement, and it was great that it was possible to ask us to join you in today's webinar or seminar, because we also heavily participate and use some of the software that is presented to you through BIM solution. And I hope that today you will be able to take something home with you, something new, something interesting, maybe refresh your already known knowledge, and then this can be good for you in your practicing engineering career as well. So today's topic is going to be beyond rebar, steel fiber reinforcement designed with RFM. And as I said, my name is Valters Sejans. So in the company, basically, I'm the design project manager, meaning I keep track of everything in design and keep everything on time, work with the engineers and technicians to deliver the project's scopes that we are required to deliver. A little bit about Premix itself. It's basically it's a research, design and build company, we could say. We have the biggest, largest privately owned concrete R&D center in the Northern Europe, where we test ourselves various materials, various mixes of concrete. We are very into full scale testing. We really like it. We think it covers a lot of problems in the standards that standards basically cannot cover. So this is our choice and our vision how things should be done. Basically, design assisted by testing. And we have many of innovation global recognition awards over the years for many of our products. Basically, yes, a lot of partners, lots of projects all around the world, also in Estonia. On that a little bit later. But generally, the scope is quite large. Data centers, gigafactories, civil industrial projects, and etc. So you name it, we build it, basically. And it's been really good, and I believe something like 30 years are already approaching for the company. So, as I said before, a little bit, we are a company specializing in steel fiber reinforced concrete and special additives for concrete as well, where we in the end call this our own patented concrete. But to start off a little bit, I want to show the concept behind the steel fiber reinforced concrete. I think it's not so new anymore, and most people know how it works, more or less. But generally, a comparison for engineers is, I think the best one is on the left side of the screen. You see a typical reinforced concrete stress block, and in the bottom you see a stress strain diagram for typical concrete, which is basically very high concrete compression strength and ability to form for a very long time during compression, but in tension very sudden basically collapse in the low tension forces. So what we do usually when using this material, we add reinforcement that can take the tensile forces, and thus we get reinforced concrete members. And on the right side, you see a typical. This is from Swedish normative for fiber reinforced concrete. Typical, let's say, analogs of those two schemas. At the top, you see the stress block for fiber reinforced concrete. So we added the fibers to the mix, and you see that basically, whereas before in the tension side of let's say a bended member, we didn't have anything from the concrete. Here we have a actual resistance mechanism. Basically, this is this steel reinforced fiber concrete that can take stresses in tension. And in the bottom, you can see why is because when adding these fibers, as compared with the stress strain diagram for concrete, we don't change anything in the compression side. It's still the same high compression strength and ductility, but what we managed to get is very, very nice ductile tension behavior of the material in about the resistance of, well, that depends on fibers, but in about the resistance of concrete itself, the tension resistance. So going forward, the science behind Primex technology and what we do. So instead of just using this very typically well-known material, which is this fiber, steel, fiber, reinforced concrete, what we do in Primex, we have our own patented technology. Is basically an expansive additive for the concrete, and with the steel fibers, this generated expansion is held together, and we get a pre-stress in the elements themselves. It's very similar to kind of pre-stressed structures known in prefabricated concrete, quite typical in flooring slabs. But this is basically done through chemical expansion. And what we do with this is basically we try to combat the shrinkage effects, which are very, very big factor in flooring applications, and actually in many, many applications where you have very large distances without expansion or contraction joints. So yes, there are many more good things about it, but the general concept is this. And typically speaking, you can see here a nice little diagram of the expansive additive that is trying to push the concrete matrix apart, and it basically anchors in these steel fibers. So you get a mechanism of about 400 microns of resisted expansion. And that is about the same as you would expect for typical shrinkage, drying shrinkage strains. So going forward is a little bit of a side note, but a very good added benefit from this is that these expansive crystals, they do feel the force of the concrete. So we've done very extensive testing as well on this item, and addition of these chemicals to the concrete makes it so that water cannot penetrate the concrete at such a depth as traditional concrete mixes. So we're able to provide with this pre-stress and the reduced cracking and water penetration, watertight solution. So a little bit going forward, and this will be very important for the RFM part and the calculations. So the core value is testing. So the company has tested many structures over the years. Full-scale tests is our go-to. Some pictures basically from the point tests and distributed load tests that we've done quite recently, actually 2023 and 2024. We've tested it to the full collapses. If you're interested, you can search this up. This is all in the internet. By typing the company, you can see all very nice materials of how it collapsed and etc. and many more things. But this is important because we can calculate many things, but we need to validate those things. We need to know whether it works like we think it works like or not. Some more pictures of the tests. And here is a little bit then in this main topic of calculations and principles and our methods and the results, and maybe hopefully you can take away and try it yourself. But how it even happens. So for fiber reinforced concrete, generally speaking, the go-to idea is that every single mix and every single ratio of fibers and every single fiber type, everything is very unique and produces a very unique mixture of things. Thus, the only way to really know what that particular mix will act like and what will be its resistance, both in SLS and ULS, you have to test it. The test methodologies, how these values for calculations later on are gotten, there are multiple. You can the two most popular are here. So there is this beam bending test, which is very, very common in Europe, and pretty much all the laboratories do it. it is one of the ways, and I would say the most popular probably, but it has its downside. And then one more very popular test is this round panel test, where round panels basically are broken. And from these tests, which provide values, basically a series of tests provides values, then these values are used for actual calculations of larger structures later on yeah, that is the core idea. Here you can see this is we own, as I said, we have this R&D center, and basically we have this accredited testing facility, like a certified testing facility in Europe, that can provide these test reports. And generally speaking, basically the companies who do provide fiber reinforcement should have these test values for you, and basically test sheets, which can then you can use for your calculations. Should provide the basic outlines. There are many places where they can order them, and they basically show the critical points in the life of the fiber reinforced concrete. So as it is, usually it is some values at certain crack widths. So for example, crack width of 0.5, crack width at 1 millimeter, crack width at 2 millimeters, crack width at 2.5 millimeters. And then they get drawn in these diagrams, etc. So what can we do with this data, and what do we do with this data, and how does RFM comes in? So we use quite often many programs, but we've found that RFM is very nice because it's quite kind of engineering program. It's not in the scientific world too much, so it's good for practical day-to-day application. And besides, more or less, it's one of the most popular softwares in the region. So many people know how to use it, and we can hire actually engineers who have background in the software. But the core concept then is from these tests that have been done in the past, we can create full stress strain diagrams, taking into account, of course, depending on the situation, what is needed to be calculated, whether it's long-term or short-term. But we can create from these points of interest, or from these tests, how this material acts both in compression and in tension. And on the right-hand side, you can see a diagram basically that shows how this looks in this isotropic damage 2D and 3D material in RFM. And this kind of a diagram can be used, and you can define your material in the software with it. Yes, then of course you can apply loads. Typically, as with principally any structure, any calculation, and you can get your results. Now I will go a little bit about what is now and what is in the future. But here you can see some of the test validations basically that we have done. So this is from one of the full-scale tests, basically a simulation, how we calculated seeing what happens in real life and trying to make a model basically out of it, and calibrate our own calculation models out from it. On the right side, this is from a little bit later, as I will explain as well. This is a research that we are currently doing in terms of basically coming up with a new system for calculating resistances with RFM 6 and new age Eurocode. But I will go into this a little bit later. First, about what is already happening. So all in all, from using these methods, so from tests to material in RFM, we can calculate for SLS stages, we can calculate easily our crack widths, and we can calculate deformations. And the nice part is that what we can do, since we have these full-scale tests, we can we can compare and see whether this is legit or is just bullshit that we're doing, basically. So so far we've done quite a bit of series of tests. One of the series, see my mouse, yes. So one of the series is, and just for a quick idea, is that deformations. We see that, for example, in this particular loading scenario, we see in RFM that we are getting 10 millimeter deflection between the supports on loaded structure. And we see from our test data, from actual real world test data, where we did load it up at the same conditions and everything, we see about 9 millimeters of actual deformation. So that matches quite nicely. So when we extrapolate and see that this happens over a series of like 7-8 tests, we see that, well, this matches quite nicely, and this RFM module, and generally speaking, is very trustable. And the same we can do for crackwoods. In the crackwoods case, we did have to script a little bit of software on top of RFM, but it is doable, especially nowadays in the artificial intelligence, where software development is kind of much more easier than before. But anyways, we can see that, for example, one of the tests, our RFM calculation model shows about 0.7 millimeter crackwood, and in real life we see about 1 millimeter crackwood. So these kind of things correlate very, very nicely and very cleanly in between real life and the models. And this is just thanks to RFM way how it handles this material. A little bit about future, what we're doing and what we're heading. So we are anticipating the 2nd generation Eurocode. I believe that will happen in Estonia as well next year or maybe in 2 years. But it will be happening in Europe global wide, and one of the key factors will be this different approach to resistance model. So currently it's based on formulas, but there you will be able to use finite element results as a proof of a resistance. And together with one of the Latvian universities, we are based on our testing, we are developing this way how to see basically collapses at certain situations of structures in the ULS stage. And basically it is we've tested some of it, and we see a very nice correlation. For now we have about 2 tests, but we see a very nice correlation, basically that at certain stage where we should expect collapse, the RFM model also deforms. Basically it gets uncontrollable deformation. So it's matching up quite nicely, both the theory, the software, and real life. So this is one of the things where we're headed. But generally the approach is the same. It's all based on these small scale tests extrapolated into this bigger model with the geometry and everything in there included. A little side note, Raft Foundation project in Estonia. Just as a side note, we actually have done projects in Estonia as well. And a little bit about maybe how that works for you as main engineers of the project. So we as a company, we take full design build responsibility. We do all the, let's say, a partner in the project. We do the design and the drawings. For this particular project, full cycle happened. Also, as I know, you have the same idea about the third-party verification and that process. So this is something we do support fully during this design stages. And yes, so this is maybe as a side note that a project like this has happened in your country as well. So yeah, some pictures from the drawings and from the model, and then from the site happening basically. So I hope I didn't go very long, and it wasn't very boring. But this is yeah, generally. And if you want to reach out to us or you have any questions, feel free to contact me or to BIM Solutions. And then I hope to hear from you, and maybe I hope that it also helps you, this kind of information.
Okay, thank you very much. I'll ask the people to have any questions. Looks like nobody has any questions, but actually have two questions for you. First is on the last slide, I saw that you only had additional rebar, like actual rebar in the connections. Like,
Yes.
where
Yes.
else do you use rebar in any other places besides the connections?
Well, generally we try to avoid it if we can, because it's quite the normal rebar spacing rules do not apply when using fiber concrete, because the spacing needs to be quite a bit bigger because of the fibers. We use it if we have very large concentrated forces, and we see
Punching.
that punching is actually very good with fibers. It is very, very good. Sometimes some very, very concentrated forces, for example, if we have very large moment and we don't want to do like 15 more kilograms per cube of fibers, we will add rebar just to take those local high moment, for example, moment locations, like over the support of a continuous slab, for example. Then we will absolutely put in rebar.
Okay, clear. And second question, what are the issues you see when migrating from RFEM 5 to 6?
Honestly, not much. We are very excited to use RFM 6 because it has some possibilities, especially on this what I described on this ULS, trying to find the maximum collapse load. In RFM 5, it's much more difficult. It's more tedious and manual, but in RFM 6, there's many good things. And for us, from my engineers, I've heard something about soil also being a much better thing in RFM 6. So I wouldn't say that I've heard any of the downsides or seen any downsides whatsoever between these softwares.
Okay, clear. Anybody else? Okay, looks like there's no more questions. Thank you very much. I think it was really interesting. And sadly, you're not here. Otherwise, I would have a little gift for you. But maybe we will meet in November, I think, at the Baltic BIM Forum. So
Yes.
I'll make sure to to thank you in some way.
Thank you. And have a great day. Thank you.
Thanks.
Okay, Tit, I guess we can shut down the Zoom. Yes, am I correct?
We can shut down the Zoom. Okay.
Okay,
Thanks.
cool. Thank you, Tit. Thank you. Bye.